Good evening, friends. Welcome to the marathon session. We are going to start the crack hydrology in 15 hours. Today is the first session.
नीलेश वेरी गुड नीलेश को भी डाउट नहीं बच्चा डाउट है तो
So, welcome to Unacademy. Let's crack it. So, welcome to Unacademy. Let's crack it. It is the largest platform for GATE and ESE cracking or any kind of preparation, any type of exam you want to go for. Please subscribe there. And this is Soumyajit Sen. And welcome to the channel Just Get Civil. We are here for Mission Gate 2021. We are here for Mission Gate 2021. And if you don't have the Unacademy Learning app still in your mobile, install it. Go to your Play Store and install this Unacademy Learning app. And what you will get daily live classes, structured courses, live test and quizzes, unlimited access. We have introduced a new thing, that is iconic subscription. There a personal coach will be assigned to you, who he or she will help you to uh, go to make the roadmap, and to go to the roadmap, always guide you for your any kind of problem. There will be study tracker. If you participate in the study tracker, plan and study booster workshops. Evaluate your progress in bi-weekly reviews with personal coach. Question answer practice you will get. All benefits of PLUs. Plus subscription. In the plus subscription, you will get daily live classes, live test and quizzes, unlimited access and structured courses. You will get the benefits of India's top educators. And while taking the subscription, don't forget to apply the code SEN10. Don't forget to apply the code SEN10. While taking the subscription, don't forget to apply the code SEN10. ACN10. Don't forget to apply the code SEN10. ACN10. Enroll today in the iconic plan or plus plan, whatever is feasible to you, but whatever it may be, don't forget to apply the code SEN10, ACN10. And these are the upcoming batches on 25th Jan 2021, Evolve for Gate 2022. While subscribing for the course, don't forget to apply the code SEN10, ACN10. Don't forget to apply the code SEN10, ACN10. Evolve for GATE 2022 in Chemical Engineering Batch A. Once again, Sen 10 is the code. Ascend for GATE 2023 for Civil Engineering. Evolve for GATE 2022 for Civil Engineering. Batch C. Ascend for GATE 2023. Batch C. And don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10 if you are subscribing for any courses. There the course link listed here.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Unacademy Combat is the India's largest fortnightly competition for GATE. Challenging and original questions curated by best Unacademy educators. Super fast and fun with all India live leaderboard. Take it live to compete with the best. Identify and improve your weak areas with detailed video solutions by top educators. Next Unacademy Combat will go live on January 26, 2021. January 26, 2021, 6 p.m. Register now for free for the batches Mechanical, Civil, Electrical, ECE and CSIT. And don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10 ACN10. Unlock, use the code CRACKGATE. So after all those introductions, so we are here to discuss about the engineering hydrology. We're starting the engineering hydrology. That is the first lecture, first session of this marathon lecture. Tomorrow morning 7 to 10 there will be another marathon lecture, and Sunday there will be another marathon lecture. After these three lectures there will be some gap in between. We will again go for the classes. We'll finish hydrology, engineering hydrology. What are the things we need to go for? We'll see what is hydrology, what are the basic process. It will be like nothing like a crash course to finish the hydrology, where you should ensure you should be confident about at least 3 to 4 marks of this total chapter. So when you're talking about the hydrological process, then if you go for the chapter disintegration, first there will be introduction. This chapter is required because to understand certain portion of the hydrology later on itself. Then we will go for the discussion of precipitation. Then we'll go for the discussion of evaporation and transpiration. Then the fourth chapter is infiltration and runoff. Hydrograph, flood and flood routing, river gauging, well hydraulics. This is actually the disintegration of the chapters of hydrology. We'll discuss what is hydrology, what are the things. Among this, the most important chapter is the hydrograph. Then the second most important chapter is the precipitation. And third most important chapter is the infiltration. From this hydrological process, hydrology, it is the part of water resource engineering. We can expect around 2 to 4 marks. Now this well hydraulics, 2 marks guaranteed. From this chapter well hydraulics, 2 marks is almost guaranteed. And rest of the portion will give you this 2 to 4 marks. Generally, one problem will come from hydrograph and one theoretical questions, or 2 problems like this it can happen. So that is the hydrology disintegrations. Any kind of doubt you can post it in the chat. So let's go for the first thing, that is the introduction to hydrology. Then each and every component I will discuss. We will not be getting any questions from river gauging, flood and flood routing generally, but obviously every chapters we will discuss as per the weightage. It's a crash course, it's not a whole detailed course, so we have to be smart in our discussion points. पहला चीज जो हम देखेंगे that is actually introduction to hydrology. जो हम पहला चीज हम लोग देखने जाएंगे that is introduction to hydrology. Generally it is not considered as the chapter, लेकिन इसके सिवाय आप बाकी चैप्टर्स में जा भी नहीं सकते हैं. जनरली इसको एक चैप्टर्स के हिसाब से देखा नहीं जाता है, लेकिन इसके सिवाय आप बाकी चैप्टर्स में जा भी नहीं सकते हैं. Now first of all, what is hydrology? It is the study of water. Hydro plus logy. Hydro means it's water, logy means the term is coming from a Greek word that means studies. It is the study of water which deals with occurrence, movement, distribution, circulation and losses below the ground, above the ground and even its atmospheric region. So if we write down the definition, hydrology is the study of water which deals with occurrence, movement, distribution, circulation and losses of water below the ground, above the ground and even in the atmospheric region. So hydrology, what I have told you already, there are two terms. One is hydro and another one is logy. And this will be of two types. Scientific hydrology and applied hydrology. So when you are talking about the scientific hydrology, there we are actually going to deal with the different components, their definitions, their how to measure them, the science of the hydrological components, and on the basis of that science, when we are going to design something hydrological parameter design, like design rainfall or any kind of flood model, then that will be come as to applied hydrology. जनरली अप्लाइड हाइड्रोलॉजी का क्या है कि अप्लाइड हाइड्रोलॉजी हमारे बीटेक लेवल या अंडर ग्रेजुएट लेवल का कहानी है ही नहीं. तो एप्लाइड हाइड्रोलॉजी में नॉर्मली क्या होते हैं कि जो बेसिक्स नॉलेज के बाद से वो हाइड्रोलॉजी जब जाता है, देयर वी विल गेट सर्टेन एम्फसाइज ऑफ द मॉडलिंग प्रोसेस, कंप्यूटराइजेशन प्रोसेस, जो हमारे इस बीटेक अंडर ग्रेजुएट कोर्स के लिए नहीं है. दैट विल कम अंडर इन द रिसर्च सेगमेंट और द मास्टर लेवल कोर्स. सो अगर हम डिसइंटीग्रेशन देखते हैं कि प्रेसिपिटेशन, इवापो ट्रांसपिरेशन, इनफिल्ट्रेशन, रन ऑफ, ये सारे हैं आपका अप टू चैप्टर 4. is everything is actually the scientific hydrology. Flood and flood routing will hydrology को आप अलग से छोड़ दीजिए, that is the ground water hydrology. जनरली वो कभी कभार आपका जियो टेक्निकल में भी पढ़ाया जाता है, उसको अलग छोड़ दीजिए. Flood and flood routing is completely the applied hydrology, and hydrograph is the bridge between the scientific hydrology and applied hydrology. Understood? Now we are going for the different components of hydrology. Then we can understand that which are the points or which are the components we have to discuss about. Different components of hydrology. Different components of hydrology. Different components of hydrology. The first one is the precipitation. The first one is the precipitation. What is precipitation? Precipitation is the process by which water will come to ground surface from atmosphere in any form. जब atmosphere से पानी ground surface पे आते हैं and in any form, that will be called as precipitation. Precipitation is the process by which water will come to ground surface from atmosphere in any form. That is the major form. That is the major form or major components of hydrology. We will see that precipitation will actually is the marathon process, which will define the other components also, which will define the formations of other components also. Second one is evaporation. Second one is evaporation. It is the loss of water It is the loss of water in the form of water vapor, in the form of water vapor from the top surface from the top surface of water body or from the pores of soil. So evaporation हम लोग पहले से ही जानते हैं, बचपन से जानते हैं कि this is the loss of water. It is the loss of water in the form of water vapor from the top surface of water body or from the pores of soil. That is called as evaporation. And evaporation will occur due to the difference in vapor pressure. Evaporation will occur due to the difference in vapor pressure and it is also called as natural vaporization process, and it is also called as natural vaporization process. Now the third component is transpiration. Third component is transpiration. What is that? It is the loss of water as water vapor to atmosphere from the soil surface by plant body. Evaporation में loss of water था water vapor के हिसाब से, लेकिन वो from the top of water surface और soil pores से था. लेकिन यहाँ पे क्या होगा? There in the transpiration it will be lost from the water from the plant body itself. Okay, from the plant body. So transpiration, it is the loss of water. It is the loss of as water vapor to atmosphere from soil surface by plant body. That is transpiration. Then we are going for the fourth component. Then we are going for the fourth component, that is infiltration. That is infiltration. The fourth component, that is infiltration. What is infiltration? It is a process by which water is transported to the soil pores by the force of gravity. So, and finally, final component is runoff. Final component is runoff. We know this. It is the amount of water flowing over the ground surface. Runoff. It is the amount of water flowing over the ground surface. It is the amount of water flowing over the ground surface or land surface, whatever it may be. Okay, now we are going for the next thing is water budget equation. A very important term we need to go for. A very important term that is called as water budget equation. Water budget equation. नॉर्मली आप ये टर्म को बहुत सुने होंगे, बजटिंग. बजटिंग का मतलब क्या होता है, आप देखे होंगे कि फाइनेंस मिनिस्टर जो है वो बजटिंग जब दिखाता है कि व्हाट इज द वे टू स्पेंड द मनी एंड व्हाट विल बी द प्रोसेस टू अर्न मोर मनी. अब ये या तो आपके पास अगर कुछ पैसा हो तो कुछ काम के लिए या कुछ फंक्शंस के लिए आप बजटिंग करते हैं, तो आपके पास कितना फंड है और उसको कैसे कैसे यूज करेंगे, दैट नीड्स टू बी डन. The water budget equation is actually the same thing, and it is based on the concept of mass balance. Mass balance concept मतलब किसका बजटिंग है, पानी का बजटिंग किसके ऊपर रिस्पेक्ट करके है. It's actually on the basis of the process of a land surface. तो इधर देखिए, अगर हम देखते हैं कि प्रेसिपिटेशन इज द इनकमिंग पार्ट. सो मास बैलेंस कॉन्सेप्ट में क्या होते हैं कि डेल्टा एस चेंज इन स्टोरेज is nothing but inflow minus outflow. The change in storage is nothing but the inflow minus outflow. That is equals to delta S, means the accumulation. It's a mass balance concept. So here, if this soil is the control volume, then precipitation is entering, evaporation is going out, transpiration is also the loss of water, infiltration is also the loss of water as it is going beneath the soil surface, and runoff is also the loss of water as it is flowing over the soil surface. So for this control volume, delta X will be equals to inflow is nothing but only the precipitation minus evaporation plus transpiration plus runoff plus infiltration. Mind it, your equation will get changed on the basis of the control volume. If the control volume is your atmosphere, then quite obviously precipitation will be the outflow, evaporation and transpiration will be the inflow. So depending on the control volume, your inflow points and outflow points will change. Here I am taking the soil surface at the control volume. That's why these are the inflows. If you take the soil pores beneath the soil surface as the control volume, then infiltration also will be an inflow. So you have to be very careful when you are taking or when you are considering the inflow points and outflow points. So that is water budget equation. Okay. Now we are going to solve one question, that is GATE 2004 questions. Very important question on the basis of water budget equation. You can understand the concept of water budget equation very clearly if you can solve this question. So a lake, let's write down the question. A lake had a water surface elevation of above the datum at the beginning of a certain month. The lake received an average inflow of 6 meter cube per second from a source in that same period. The outflow from the lake had an average value of 6.5 meter cube per second. Further in that month, the lake received a rainfall of receive a rainfall of 145 mm and the evaporation was estimated as 6.1 centimeter. Calculate the water surface elevation at the end of the month. If the surface area is 5,000 hectare. Solve it. Solve this question, please. Solve these questions. The statement seems like it's a bigger statement. So, but the solving process will be very easy if you understand it. Try to understand. Read the statement, then solve it. A lake had a water surface elevation of 103.2 meter above the datum at the beginning of a certain month. The lake received an average inflow of 6 meter cube per second from a source. In that same period, the outflow from the lake had an average value of 6.5 meter cube per second. Further, in that month, the lake received a rainfall of 145 mm and the evaporation was estimated as 6.1 centimeter. Calculate the water surface elevation at the end of this month. Surface area is 5,000 hectare. So let's solve this question. By solving this question, you can understand the concept of water budget equation clearly. So actually, if this is a lake surface, that is a control volume, something is inflow, precipitation is occurring, evaporation is occurring, and some water is going out. So your delta S, change in storage, will be inflow minus outflow. So delta S, what is your inflow? 6 meter cube per second water. This is 6 into 24 into 3600, that is for a day, and for a month they're asking into 30 plus. Precipitation is also occurring. What is precipitation? 145 mm. So 145 by 1000, that is the depth of precipitation. You need to find out the volume, then volume will be multiplied by area, 5000 hectare, in 10 to the power 4, right? Outflow is 6.5 meter cube per second into 24 into 3600 into 30 plus 6.1 centimeter evaporation, that is the loss. 6.1 centimeter by 100 into 5000 into 10 to the power 4, because hectare is converted into meter square. Is that clear? Now we are going for the calculation. Delta S, if you take 5000 into 10 to the power 4 common, it will be 0.145 minus 0.061, and if you take 24 into 3600 into 30 common, it will be, as it is minus is there, so it's 6.5 minus 6. Clear? From this equation, have a look. तो भैया यहाँ पे है कि डेल्टा एस, इसमें क्या है, ये वॉल्यूम के ऊपर आधारित है, लेकिन आपका फाइनल क्वेश्चन में चाह रहा है कि एलिवेशन. सो डेल्टा एस डेप्थ, चेंज इन स्टोरेज इन डेप्थ, ये सारे वॉल्यूम को हम लोग क्या करेंगे, एरिया से डिवाइड कर देंगे. सो 0.145 माइनस 0.061, ये तो हट जाएगा, माइनस 24 इंटू 3600 into 30 into 0.5 by 5000 into 10 to the power 4. Is that clear? Now it is coming as 0.058 meter. So final depth कितना होगा, initial depth plus, जब ये यहाँ पे पॉजिटिव है मतलब height of water get increased. So final depth will be initial depth 103.2 plus 0.058, that is the increase in depth, meter 103.258 meter. Is that clear? So after this, if we need to discuss about the application of hydrology, what will be the application of hydrology? ये कौन कौन कामों में यूज होते हैं? Like it is used to design the hydraulic structures. It is used to design the hydraulic structures. The knowledge of scientific hydrology will be applied at flood and flood management. The knowledge of scientific hydrology will be applied at flood and flood management. The concept of hydrology will be used for irrigation estimation, quite obviously. They are interrelated. Hydrological parameters are also used for distribution of water and domestic water supply engineering. Okay. Now we are going for the official first chapter. Before that, don't forget to subscribe the YouTube channel for GATE and ESE cracking process. Use the code SEN10 ACN10. Hit the bell icon for notification and join our Telegram group for latest updates on our upcoming videos. Now we are going for the precipitation. The official, which is the chapter 1, is the precipitation. So what is precipitation? We have discussed the definition already. It is the what? Is the process by which water will come to ground surface from atmosphere in any form. It is a process by which water will come to ground surface from atmosphere in any form. And what will be the forms we will discuss. Before that, we need to discuss that to form the precipitation. Precipitation को बनने के लिए चाहिए. The atmosphere must have enough moisture content. अगर moisture content नहीं रहेगा, मैं लिख नहीं रहा हूँ, just discussing with you. If the atmosphere does not contain the sufficient moisture content, the precipitation will not be formed. There should be sufficient particles present to initiate the condensation process. Weather condition must be very good for condensation. And finally, we need to remember that the condensed matter should reach the ground surface. The condensed matter should reach the ground surface. Now, as I have already told you that there will be different forms of precipitation. So let's discuss the different forms of precipitation. The first form is the most common one, is the rainfall or rain. The term rainfall is used to describe the writings are visible. Precipitation in the form of water droplets, where size of the water droplet may vary in between, where size of water droplet will vary in between 0.5 to 0.5 to 6 mm. In between, the size of the water droplet will vary. That is rainfall or rain. Second one is snow. It is the form of precipitation when the water comes as solid, and the density will vary in between. When water comes as solid and density will vary in between. Point 0.06 to 0.15 gram per centimeter cube. The density will vary in between 0.06 to 0.15 gram per centimeter cube. That is second form, that is snow. Third one is drizzle. क्या है drizzle? ये भी एक रेनफॉल ही है, लेकिन सिर्फ उसका साइज होंगे 0.5 से छोटा. It is also a type of rainfall, but the size of water droplet will be less than 0.5 mm. It is also a type of rainfall. Size of water droplets will be less than 0.5 mm. That is drizzle. Then the fourth type is hail. Quite obviously, if the drizzle is less than 0.5 mm, so hail will be water droplet size more than 6 mm. It is also a type of rainfall. Where water droplet size will be more than 6 mm. So 0.5 to 6 mm will be the rainfall, less than 0.5 will be drizzle, and greater than 6 mm will be hail. And there are one more thing is glaze. What is glaze? Sometimes rainfall or drizzle come across to ground surface, which is having the temperature 0 degree centigrade or less than that. Then after coming across, it will form a thin layer of ice above the ground surface. It is called as glaze. When rainfall or drizzle come across with ground surface, having temperature zero or less than zero. Then it will form a thin layer above the ground surface. That is glaze. Another one is there, that is hail, when rainwater comes along with particles. It's called as hails. Now we'll discuss about the type of precipitation. Types of precipitation. So there are generally 4 types of precipitations observed. I'll just describing it, not writing anything. Convective rainfall, cyclonic rainfall, orographic rainfall, and frontal rainfall. There are 4 different types of rainfall generally observed. Just a minute. In case of convective rainfall, what will happen? कन्वेक्टिव रेनफॉल के टाइम में क्या होता है कि ये नॉर्मल प्रोसेस है, वार्म एयर मास ऊपर जाते हैं और वार्म एयर मास जब ऊपर चढ़ते हैं और चढ़ने की वजह से when the along with the air vapor or moisture precipitation will occur. Cyclonic में भी same process but it be speedy process. Orographic rainfall normally क्या होते हैं कि warm air mass goes upside along with the slope of a hilly region and it will shed huge amount of rainfall. एक पहाड़ के साइड में बहुत ही ज्यादा पानी होता है, उसको कहते हैं विंडवर्ड साइड, और एक साइड में पानी का क्वांटिटी बहुत कम होते हैं, उसको कहते हैं लीवर्ड साइड. मुंबई, पुणे, थाने, मुंबई सॉरी नॉट पुणे, मुंबई, लोनावाला, थाने, खंडाला, these are in the windward side of Western Ghats. Pune is in the leeward side of Western Ghats. फ्रंटल रेनफॉल क्या है? नॉर्मली इसको लोकल रेनफॉल कहते हैं. फ्रंटल रेनफॉल को कभी कभार वार्म एयर मास ऐसे नॉर्मली जा रहे हैं, सोच लीजिए अचानक से इसको धक्का अगर कोई कोल्ड एयर मास से लगता है तो वार्म एयर मास will rise at the above of the cold air mass and at the junction it will cool down, sudden cool down, rainfall occur. इसको कहते हैं वार्म एयर फ्रंट. और कभी कभार कोल्ड एयर मास चलता रहता है और ये जाके वार्म एयर मास को धक्का मारता है, तो वार्म एयर मास को अपनी जगह से हटा के ऊपर चढ़ा देता है और नीचे आ जाता है कोल्ड एयर मास. एंड कहानी दोनों के लिए सेम है, सिर्फ एक में वार्म एयर मास चल के जाके धक्का मारता है और एक में कोल्ड एयर मास जाके धक्का मारता है. जहां पे वार्म एयर मास जाके धक्का मारता है उसको कहते हैं वार्म एयर फ्रंट. और जहां पे कोल्ड एयर मास जाके धक्का मारता है उसको कहते हैं कोल्ड एयर फ्रंट. होप इट इज क्लियर टू यू. Okay, now we are going for a very important thing that is called as characteristics of rainfall. To find out the characteristics, first of all, there will be depth. Second one is duration. And third one is the intensity. These are the main characteristics. Depth is the amount of rainfall occurred. इसका यूनिट क्या होता है डेप्थ का? mm, centimeter. Length unit. Duration, the duration of rainfall. Intensity is depth by duration only. Velocity unit. Okay. इसके सिवाय एक और यूनिट, एक और कैरेक्टरिस्टिक्स हैं, that is called as return period. That is called as return period. What is return period? It is a time gap. समझने का कोशिश कीजिए इसको. Time gap between reoccurrence of a rainfall event. अब रेनफॉल इवेंट का मतलब है, ये रेनफॉल इवेंट ऐसा कोई नहीं है कि एक सिंगल पैरामीटर है. रेनफॉल इवेंट का मतलब है या तो ये फंक्शन है डेप्थ और ड्यूरेशन का, और नहीं तो इट इज फंक्शन ऑफ इंटेंसिटी एंड ड्यूरेशन. इसका मतलब क्या है? 5 सेंटीमीटर डेप्थ ऑफ रेनफॉल फॉर 2 आवर ड्यूरेशन, दैट इज एन इवेंट. 2 सेंटीमीटर पर आवर इंटेंसिटी ऑफ रेनफॉल फॉर 2 आवर 5 आवर ड्यूरेशन, दैट इज एन इवेंट. 5 सेंटीमीटर रेनफॉल, इट इज नॉट एन इवेंट. इवेंट या तो होगा आपका डेप्थ के और ड्यूरेशन के साथ, नहीं तो होगा इंटेंसिटी और ड्यूरेशन के साथ. या तो होगा ये डेप्थ ड्यूरेशन के साथ, नहीं तो होगा ये इंटेंसिटी ड्यूरेशन के साथ. दैट इज एन रेनफॉल इवेंट. और टाइम गैप बिटवीन रीऑकरेंस ऑफ अ रेनफॉल इवेंट इज कॉल्ड एज रिटर्न पीरियड. इसका मतलब क्या है? सोचिए आज का डेट में है आपका 22 जनवरी. आज का डेट है आपका 22 जनवरी. On 22nd January in your area, a rainfall event has occurred of 5 centimeter per hour for 2 hours duration. Or we can say that 10 centimeter depth of rainfall occurred for 2 hours duration. ये rainfall event जो है, ये rainfall event आपका खैर वो फिर से on 22nd January 2022 में रिऑकर किया. तब क्या होगा? तब बोला जाएगा कि द रिटर्न पीरियड ऑफ दिस रेनफॉल इवेंट 5 सेंटीमीटर पर आवर फॉर 2 आवर्स ड्यूरेशन for this catchment area is 1 year or 365 days or 12 months. Is that clear? So rainfall event will be always discussed in the function of two parameters, depth duration or intensity duration. It is not a single it is not a function of a single characteristics. And return period is nothing but the time gap between the reoccurrence of that rainfall event. Time gap between the reoccurrence of rainfall event. Now we are going for the rainfall measurement. Shekhar, अभी तक clear है? What about the return period? We will solve certain problems also later on. शेखर, आपने पूछा कि रेनफॉल इवेंट का ड्यूरेशन 1 डे का भी हो सकता है क्या? देखिए 1 डे का रेनफॉल, 1 डे मतलब लगातार आपका हो रहा है, 24 घंटा लगातार हो रहा है। उसमें ऐसा तो नहीं होता है कि 24 घंटा लगातार सेम इंटेंसिटी में रेनफॉल हो रहा है। हो तो सकता है, देयर आर सर्टेन आउटलायर्स आर देयर। जैसे 2006 में 2006 26 ऑफ जून क्या है कि आपका एक रेनफॉल इवेंट हुआ था, मैं जस्ट बता रहा हूं, सांता क्रूज में, मुंबई में। that is for 934 millimeter rainfall in 24 hours. Depth is 934 millimeter, which is the outlier, and जिसका रिटर्न पीरियड है 400 years। मतलब वैसा रेनफॉल इवेंट आपका 400 साल बाद फिर आएगा। अब 400 साल मतलब समझ गए हैं कितना जनरेशन होता है हमारा। एंड यू कांट डिजाइन एनीथिंग, और कोई डिजाइन का आपका मतलब डिजाइन पीरियड 400 years नहीं होता है। मैक्सिमम इट इज 100 years, which is for landfill. Is that clear, Shekhar? So it can happen, but it's very likely rare. हाँ, अगर आप बोल सकते हैं कि डेप्थ, टोटल डेप्थ ऑफ रेनफॉल के साथ 1 डे का, then it's okay. But there should be a continuous rainfall process. Okay. Now we are going for the rainfall measurement. The rainfall measurement will generally it is done by two way. One is recording type, another one is non-recording type. Recording type examples are tipping bucket method, where human involvement is required. Siphon rain gauge is also the example of recording type. Radar measurement. Non-recording type. Examples are IS rain gauging, Simon rain gauge. Now we need to go for, before going to that, we need to understand one thing that I am telling you. sorry, spelling mistake. Adequacy of rain gauging station number. बात ऐसा है कि रेनफॉल इज स्पेशियली वेरिएबल एंड टेम्पोरली वेरिएबल। इसका मतलब क्या होता है? इसका मतलब क्या होता है? रेनफॉल इज स्पेशियली वेरिएबल एज वेल एज टेम्पोरली वेरिएबल। स्पेशियली वेरिएबल मीन्स इट्स एक्चुअली 3 डायमेंशनल, इट इज वेरिएबल। लाइक आपके घर में के बगल में घर पे जहां पे है वहां पे अगर आपके पास कोई रेनफॉल हो रहा है, थोड़ा सा दूर जाइए, 500 मीटर 600 मीटर या 1 किलोमीटर दूर जाइए, वही सेम इंटेंसिटी में सेम रेनफॉल हो रहा है, इसका गारंटी आप नहीं दे सकते हैं। एंड टेम्पोरली वेरिएबल मीन्स आज के डेट में जो रेनफॉल हो रहा है, 1 साल बाद एग्जैक्टली उतना ही रेनफॉल होगा, इसका गारंटी भी आप नहीं दे सकते हैं। So rainfall is spatially and temporally variable. That's why measuring and representing rainfall is bit tough. Why? Because of the dimensionality. अगर ये सिर्फ स्पेशियली वेरिएबल होता तो 3 डायमेंशनल प्रोसेस होता, लेकिन यहाँ पे एक्स वाई जेड के साथ और एक एक्सिस जुड़ता है जिसको मेजर करना इज नॉट अ केकवॉक व्हिच इज टाइम एक्सिस। जैसे मैं एक एग्जांपल अभी आपको दिया जो सांता क्रूज में मेजर किया गया था, और उससे ही 14 किलोमीटर दूर, that's 14 kilometers away from that Santa Cruz, that event 934 mm in 24 hours, उससे ही 14 किलोमीटर दूर कोलाबा का जो रेन गेजिंग स्टेशन है मुंबई में ही, that rain gauging station has recorded 74 mm in 24 hours. So कहां 934 मिलीमीटर और कहां 74 मिलीमीटर? So that is the sole reason to estimate, to represent rainfall properly, or to forecast the rainfall properly, we need to have more and more data. More and more data means the lesser error you will commit in case of statistical calculations. That is the thing we are going to read here. We need to find out whether the rain gauging station's number for a particular catchment is adequate, is sufficient or not, or what will be the sufficient number to represent the rain gauging station's data with a minimal error. So suppose there are certain stations are there and they are measuring certain. So station 1 is measuring annual average data as P1, station 2 is measuring P2, station 3 is measuring P3, like this. M number of station or mth station is measuring PM. So optimal number of stations to tell it is adequate n is equals to Cv by epsilon whole square, where epsilon is the allowable degree of error, which is always 10% if it is not provided, and Cv is the coefficient of variance of given data, where Cv is equals to 100 into sigma m by p bar, where p bar is the mean precipitation, that's equals to summation of I equals to 1 to m pi by m. Adequacy of rain gauge stations, m stations are there, annual average is p1 to pm, where optimal number of stations to tell it is adequate n is equals to Cv by epsilon whole square. Epsilon is allowable degree of error, always 10% generally. Sigma m is equals to under root summation of I equals to 1 to m pi minus p bar whole square whole by m minus 1. Quickly have a look. We will solve a question. Okay, let's solve a question. That's also a gate question, and this type is very important for gate also. A catchment is having 6 rain gauging stations A, B, C, D, E, F, and annual data measured by the stations are estimate the number of stations to be added to the present one to tell that the catchment is adequate with the number of rain gauging station values. Epsilon as 10%. So to solve this question, first P bar we need to calculate summation of all P by 6, that will be equal to 118.6 mm. We need to calculate sigma m, that is 82.6 minus 118.6 squared plus 102.9 minus 118.6 squared, to keep on the values by 6 minus 1, it will be 35.04. CV will be 100 into 35.04 by 118.6, 29.54. N is 29.54 by 10 whole square. It's 8.72, almost equals to 9. So already 6 is present. How much you need to add? We need to add 3 itself. Already 6 is present. We need to add 3 to make it adequate, or to tell that the catchment is adequate with the number of rain gauging stations data. That means the data you are going to get, you are going to process with a minimal error. 10% error is allowed here. 10% error is allowed. Now The next topic from the precipitation is the preparation of data. जब भी आप जाते होंगे कोई सा भी आपका प्रोसेस में कि कोई भी हाइड्रोलॉजिकल डिजाइंस के लिए या तो कोई भी हाइड्रोलॉजिकल एस्टिमेशंस के लिए जब भी आप जाते होंगे देन व्हाट यू नीड टू हैव द थिंग यू नीड टू बी कंसर्न्ड अबाउट द रेनफॉल डेटा, क्योंकि रेनफॉल डेटा कोई छोटा मोटा डेटा से ऊपर बात नहीं होता है, ये दैट विल बी कभी कभार 40-45 साल 50 साल का बात होते हैं, तो इसका डेटा को देखना पड़ता है। इट विल बी रिप्रेजेंटेड इन अ मैट्रिक्स फॉर्म, इट कैन बी आवरली रेनफॉल डेटा। आप सोच सकते हैं कि एक साल के लिए कितना आवर्स कितना डेटा हो सकता है, और अगर 30-35 साल का कहानी है तो कितना लंबा डेटा चलेगा सेट। तो इसको थोड़ा सा सैनिटाइज करना पड़ता है इस डेटा सेट को, दैट इज इंपॉर्टेंट। एंड इन प्रिपरेशन ऑफ प्रेसिपिटेशन डेटा टू फैक्टर्स शुड बी मेजर्ड। वन इज कंटिन्यूटी, दो चीज को मेजर करना पड़ता है, एक है कंटिन्यूटी और एक है कंसिस्टेंसी। सो इन प्रिपरेशन of precipitation data, two factors should be measured. Continuity, consistency. Now first we are going for the continuity measurement. कंटिन्यूटी का मतलब है सारे डेटा है कि नहीं, अगर नहीं है तो हाउ टू डील विद दैट फैक्टर। हम ब्लैंक नहीं रख सकते हैं, अगर हम ब्लैंक रखेंगे तो जो जहां पर जब कंप्यूटर में फीड करेंगे तब वो जीरो पकड़ लेगा। So continuity measurement is called as the estimation of missing data. अगर if the data set is not continuous, कहीं पे डेटा मिसिंग है, you have to estimate the missing data. You have to feed some values. So suppose for this process, so there are certain suppose for there are 5 stations A, B, C, D, X. For A, the data set is PA. Yes, I got your answer. Thank you. Good. For B, it is the annual data is PB. CPC sorry, this will be PD, and the annual average data NA, it is for NB, NC, ND, NX. Try to understand very carefully. So the total number of stations is 5. And number of adjacent stations are is 4. Total number of stations are 5. Number of adjacent stations are 4. And N is the annual average data. Annual average means not generally it is for last 30 years average. तो क्या होगा कहानी? तो सोचिए कि 2000 से लेके 2030 तक का डेटा का एवरेज है पांचों स्टेशंस का, सबका सोचिए 2010 का वैल्यू जो है एक्स का जो वो मिसिंग है, बाकी सबका है. हाउ टू डील विद दिस? टू फाइंड आउट द एस्टिमेट और टू एस्टिमेट द मिसिंग डेटा, two methods can be used. Two methods can be used. Two methods can be used. One is simple mean method, and second one is normal ratio method. अब दोनों मेथड के लिए कंडीशंस हैं. For both the methods, conditions are there. What are the conditions? So in simple mean method, जिसका डेटा मिसिंग है उसका 30 years annual average NX should be in between plus minus 10% of NA, plus minus 10% of NB, plus minus 10% of NC and plus minus 10% of ND. मतलब जितना आपका एडजेसेंट डेटा है, एडजेसेंट जितना भी स्टेशन हैं, उसका एनुअल एवरेज डेटा का प्लस माइनस 10% के अंदर होना चाहिए एक्स का एनुअल एवरेज डेटा. तभी आप सिंपल मीन मेथड अप्लाई कर पाओगे. सोचिए कि ए के लिए सेटिस्फाई किया, बी के लिए सेटिस्फाई किया, सी के लिए सेटिस्फाई किया, लेकिन डी के लिए नहीं किया, तब भी आप सिंपल मीन मेथड अप्लाई नहीं कर पाओगे. Then also you won't be able to apply simple mean method. You need to go for the normal ratio method. चारों के चारों सबका सब adjacent stations data के साथ इसको satisfy करना है. Then only you can go for the simple mean method. Then if each and every conditions are satisfied, then Px will be equals to nothing but Pa, that's nothing but the average value by 4, or general equation should be summation of I equals to 1 to m minus 1 pi by m minus 1. Why 1 to m minus 1? So m is actually the total number of stations, और यहाँ पे कितने सारे का ऐड किया आपने? m minus 1 is number of adjacent stations. यहाँ पे हिंच है, समझना है आपको. Number of adjacent stations. Clear? Now we are going for the normal ratio method. Normal ratio method. In normal ratio method, Px will be equals to Nx by n minus 1 number of adjacent data into PA by Na plus PB by NB plus PC by NC, like this, Pm minus 1 by M minus 1. That is your normal ratio method. Quickly have a look to this process, then we will proceed further. Just a minute. Have a look, please. Simple min method. पहले ये चीज है कंटिन्यूटी मेजरमेंट. Normal ratio method. Now we are going for the consistency checking. Now we are going for the consistency checking. Just take a note that the consistency checking is done by plotting. Just you remember this, because plot, you don't have to go for any plot in the GATE exam. Double mass curve. There's another term called mass curve. What is that? I will discuss later. It is double mass curve. What is double mass curve? It is the plot of cumulative annual rainfall of the station for which consistency checking is required versus cumulative mean annual rainfall for the base stations. Base stations means adjacent stations. For the base stations, which is nothing but the adjacent stations. Okay, so continuity checking is done by the process of finding out simple mean method or normal ratio method, and the consistency checking is done by the plot of double mass curve. What is the double mass curve plot? I have told, not described but told. Now we are going for representation of data. Very important. Representation of data. Now represent this. So we have done for the preparation of data. Now we need to represent the data. Now representation of data can be done in different ways. First of all, it can be done by the process of mass curve. First of all, that is mass curve, not double mass curve. Double mass curve is for the consistency of the mass curve. It is a plot of cumulative annual rainfall data for a particular catchment with respect to time. And the plot will be in chronological order. And the plot will be in chronological order. So it will be a plot where cumulative data values will be plotted like this. If it is for 2001, 2002, it will happen. Okay. The next one is the most important one. And once again, please understand the process very carefully. Called as hydrograph. Hydrograph, not hydrograph. Hell and heaven difference between hydrograph and hydrograph. Please understand hydrograph carefully. Hydrograph. It is a plot of intensity of rainfall versus a fixed time interval and plotted in a bar chart diagram. That means if you overview a hydrograph, it will look like fixed time interval from 0, 1, 2, next 3, it's 4. I in mm per hour, let it be. T is in hour. So each and the area under these bars will provide you the I into T, which is the depth of rainfall. So total area under the curve will be total depth of rainfall. And remember, ये हाइड्रोग्राफ वाला जो पॉइंट्स हैं, जो आपका पॉइंट्स है, जो मतलब टाइम गैप है, उसको आप डिफाइन कर सकते हो. यहाँ पे 1 आवर का डिफरेंस है और 2 आवर्स के डिफरेंस में भी रिप्रेजेंट हो सकते हैं. लेकिन एक चीज याद रखना कि द टोटल एरिया अंडर द कर्व व्हिच इज द टोटल डेप्थ ऑफ रेनफॉल विल बी ऑलवेज फिक्स्ड. एक चीज याद रखना कि टोटल एरिया अंडर द कर्व व्हिच इज द टोटल डेप्थ ऑफ रेनफॉल विल बी ऑलवेज फिक्स्ड. मैं आपको एक एग्जांपल दिखा रहा हूं कि हाउ टू प्लॉट द हाइड्रोग्राफ along with certain difference between the area of this along with this certain fixed depth of rainfall. Then again same data के ऊपर आपको आपके लिए एक काम भी दूंगा, वो भी आपको करना पड़ेगा. Example 1, just an example. सोचिए टाइम है, ऐसा डेटा आपके पास है 0 to 2 और डेप्थ दिया हुआ है 10 सेंटीमीटर और mm, whatever it may be, mm. चलिए, दिस इज आवर. रात को 12 बजे से डेटा आपके पास है, ठीक है. उसको हाइड्रोग्राफ में प्लॉट करना है. 2 to 3 के लिए 3 नॉन यूनिफॉर्मिटी है. 3 to 6 के लिए है आपका 12. 6 to 7 के लिए है आपका 7. 7 to 9 के लिए है 16. 9 to 12 के लिए है आपका 27. यह है आपका डेटा. आपको बोला गया है कि हाइड्रोग्राफ प्लॉट करो. You have asked to find out the hydrograph or plot the hydrograph on 1 hour time interval, जो आपके पास है ही नहीं 1 hour time interval, लेकिन आपको प्लॉट करना है. कैसे करेंगे? What will be the process? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. ओके, देखिए, ट्राई टू अंडरस्टैंड वेरी केयरफुली. ये समझिए, ये समझने से आपके बेटर है हाउ टू सॉल्व दिस. ट्राई टू अंडरस्टैंड. तो इधर है आपका आई, करेक्ट, इन mm पर आवर, और इधर है आपका टी इन आवर. तो 0 to 2 रात को 12 बजे से 2 बजे तक आपके पास क्या है? सो इट्स एक्चुअली द प्लॉट ऑफ एवरेज इंटेंसिटी. रात को 12 बजे से 2 बजे तक 10 mm बारिश है. एवरेज इंटेंसिटी में कितना होगा? 5 mm ईच. तभी तो आपका टोटल डेप्थ आपको फिक्स रखना है. दैट इज द मेन मोटो. देखिए टोटल डेप्थ फिक्स हो रहा है कि नहीं? अगर इसका है आपका 5 mm पर आवर इंटेंसिटी इंटू 1, इट्स 5 mm डेप्थ. इसका डेप्थ है कितना? 5 mm, क्योंकि ये तो डिफरेंस है 1 आवर का. तो टोटल डेप्थ है आपका 10. समझ में आया कि नहीं? डेप्थ में असली चीज, यहाँ पे डेप्थ कितना है? 5. यहाँ पे डेप्थ कितना है? 5. यहाँ का टोटल डेप्थ कितना है? पहले कैलकुलेटर के रख दीजिए. 10 + 3 13 + 12 25 + 7 32 + 16 48 75 है डेप्थ, टोटल डेप्थ. देखते हैं क्या होता है इधर. 2 to 3 के लिए 3 है. इसका मतलब है उसी में प्लॉट होगा 3. 1 आवर का पानी है तो इसका डेप्थ कितना हुआ? चलिए 3 to 6 के लिए 12 है, मतलब 3 to 4, 4 to 5, 5 to 6, मतलब 3 घंटे के लिए 12, मतलब फॉर ईच आवर इट शुड बी 4 4 4 4 6 to 7 के लिए 7, मतलब 1 घंटे के लिए 7, मतलब वहां पे 7 mm पर आवर डेंसिटी। 7 to 9 के लिए 16, मतलब 7 to 8 के लिए भी 8, 8 to 9 के लिए भी 8, 9 to 12 के लिए 27, मतलब 9 to 10 के लिए भी 9, 10 to 11 के लिए 9, 11 to 12 के लिए भी 9। इंटेंसिटी वैल्यू अगर आप यहाँ पे डेप्थ कैलकुलेट कर लेते हो, सो 3 into 1 it's 3, it's 4, it's 4, it's 4, 7, 8, 8, 9, 9, 9, कितना होगा टोटल डेप्थ? 5 plus 5, 10 plus 3, 13 plus 4, 17, 21, 25, 32, 40, 48, 57, 66, it's 75. So total depth is constant. Sorry. So total depth of rainfall is constant. Total depth of rainfall is constant. Clear? Now plot it. Plot the same data with 2 hour time duration, 2 hour time gap. मतलब मैं क्या चाह रहा था, इसमें प्लॉट कीजिए. प्लॉट द सेम डेटा इन 2 hour टाइम गैप. अभी प्लॉट कीजिए इसमें सेम डेटा को. 0, 2, 4, 6, 8, 10, 12. अब मजा आएगा. प्लॉट कीजिए, सेम डेटा को प्लॉट कीजिए. सुमन, वेट. कॉफी लो, कॉफी कॉफी
से করে দিয়ে যাবো না
10 7 8 15 7 18 चलते चले सुमन, देखते हैं 10 कैसे होगा सुमन, पहला ही तो गलत है। इंटेंसिटी होगा ना, आप इंटेंसिटी का वैल्यू बोल रहे हो ना। समझने की कोशिश कीजिए, देखिए 0 to 2 में 5 plus 5, हाँ 5 plus 5 that is depth सुमन, try to understand, see try to understand सुमन प्लीज। 0 to 2 में आपका टोटल डेप्थ कितना है, टोटल डेप्थ है आपका 10। तो इंटेंसिटी आप जब प्लॉट कर रहे हो इधर, यहाँ पे टाइम है, तो टोटल डेप्थ इज 10 mm, टाइम इज हाउ मच 2, तब आपका हुआ इंटेंसिटी है 5, इट शुड बी 5, तभी ना आपका डेप्थ कितना होगा, सोचिए 5 mm per hour into 2 hour, then only your depth is 10। क्लियर? ओके, चलिए देखते हैं। देखिए 0 to 2 के बाद है 2 से 4, ट्राई टू अंडरस्टैंड 2 से 4, 2 से 4 आपके पास है ही नहीं डायरेक्टली, 2 से 4 का मतलब क्या है, 2 to 4 मीन्स 2 to 3 प्लस 3 to 4, 2 to 3 में आपके पास कितना बारिश हुआ है 3, और 3 to 4 में आपके पास बारिश कितना है, 3 to 6 में है आपका 12, 3 to 6 में है आपका 12, मतलब 3 to 4, 4 to 5, 5 to 6 सब में आपका 4 करके है, इट्स 4, तो टोटल है 7 है, लेकिन कितना घंटे में है, 2 घंटे में। तो ये वैल्यू कितना होना चाहिए, इंटेंसिटी वैल्यू 7 है, टोटल डेप्थ कितना घंटे में है, 2 घंटे में, तो भैया ये तो होगा 3.5। It will be 7 only. Clear? Now it is correct, Suman. Let's see. 3 to 6 तो अभी क्या है, 4 to 6, 4 to 6 मतलब 4 to 6 का मतलब क्या है, 4 to 6 का मतलब है 4 to 5 प्लस 5 to 6, राइट। 4 to 5 में आपका 4 है, 5 to 6 में भी 4 है, टोटल में आपका है 8, लेकिन कितने घंटे में है, 2 घंटे में है, तो मतलब आपका इधर होगा 4 to 6 में 4, तब जाके आपको मिलेगा ये 8। अब क्या है 6 to 8, 6 to 8 के लिए आपके पास क्या है 6 to 7, 6 to 8 के लिए आपके पास है 6 to 7 प्लस 7 to 8, तो 6 to 7 में है आपका 7, 7 to 8 में है आपका 8, तो 7 प्लस 8 इज इक्वल टू 15, तो ये है 2 घंटे में, मतलब 7.5 का कहानी है इधर, सो इट्स 7.5 फॉर 6 to 8, 7.5 मिलने से आपको मिलेगा 15। अब है कहानी 8 to 10 का, तो 8 to 10 का कहानी में आपके पास क्या है 8 to 9 से 9 to 10, तो 8 to 9 है आपका 8, 9 to 10 है आपका 9, तो इट विल बी 8 प्लस 9 विच इज 17, मतलब कहानी है आपका 8.5 का, सो देयर विल बी 7.8 8.5, then only you are going to get 17. Now it's 10 to 12. 10 to 12 का मतलब क्या है? 10 to 11 plus 11 to 12. 10 to 11 भी है 9, 11 12 भी है 9. 9 plus 9, 18. So 10 to 12 will be equals to 9 only. तो उसके अब देखिए ऐड कर कीजिए इसको यहाँ पे 10 plus 7 17 plus 8 25 40 57 75. Is that clear? सुमन सही है? क्या भैया? सुमन का वैल्यू कितना है? होप इट इज क्लियर टू हिम. तो अगर आपके पास अगर आप इसको समझ गए हैं ना तो अभी आप इसको लेके खेल सकते हो. आप इसको 3 आवर का ड्यूरेशन में कर सकते हो. 0 3 6 9 12 4 घंटे के में कर सकते हो. दैट कैन यू कैन डू बट कीप इन माइंड कि टोटल ड्यूरेशन टोटल डेप्थ ऑफ रेनफॉल विल बी फिक्स्ड. ओके. Let's go for the third representation. IDF and DDF curve. IDF and DDF curve. IDF means intensity, duration, frequency curve. And DDF means depth, duration, frequency curve. IDF is actually intensity versus duration plot for a fixed frequency return period. 1 return period, 2 return period, 3. And any two IDF curves cannot cut. That means it can show that it is the for a fixed event, a return period will be fixed. For a fixed event, a return period will be fixed. If you increase the event dimensions, return period will be more. ज्यादा से ज्यादा डायमेंशन का रिटर्न पीरियड ज्यादा होते हैं और टू आईडीएफ कर्व और टू डीडीएफ कर्व कैन नॉट कट ईच अदर बिकॉज टू आईडीएफ कर्व और टू डीडीएफ कर्व कैन नॉट कट ईच अदर बिकॉज अगर सोचिए ऐसे दो कट कर गया तो एक ही इवेंट का दो रिटर्न पीरियड विच इज नॉट पॉसिबल. टू प्लॉट two values will not cut each other. सुमन काफी टाइम लग रहा है आप मेरे तक चैट पहुंचने में, क्या ही करूं मैं। एनीवेज चलिए अभी तक कर तो लीजिए, काफी आगे भी निकल चुके हैं हम लोग। वी आर इन द राइट ट्रैक। टू वैल्यूज विल नॉट cut together. Why? Because for a single event, tool and period is not possible. IDF and DDF curve. Same concept. The fourth one is DAD curve. Once again with the same concept, but just the name is different. Just you need to know the name. DAD curve. DAD is depth, area, duration. Depth, area, duration curve. This is depth to area plot for different durations T1, T2, T3 and T1 less than T2 less than T3. That's you need to remember. That is depth area duration curve plot. So कैसे हम कोर्स को सजाए हैं, पहले हम पूरा थियोरेटिकल एस्पेक्ट्स को डिस्कस कर लेंगे अपार्ट फ्रॉम दिस वेल हाइड्रोलिक्स, उसको हम थोड़ा सा लास्ट में देखेंगे। और फिर हम लोग एक सेशन होगा ऐसा, मतलब और एक सेशन मतलब अभी जैसे लंबा चल रहा है, पहले हम प्रेसिपिटेशन कर रहे हैं, इसके बाद प्रेसिपिटेशन का खत्म होते ही हम एक छोटा सा 5 मिनट का ब्रेक लेंगे और चलेंगे इवेपोरेशन ट्रांसपिरेशन के पास, फिर इन्फिल्ट्रेशन रन ऑफ। इफ देन टाइम परमिट्स विल गो फॉर द, सो टुमारो मॉर्निंग सेशन विल बी very important where we will deal with this hydrograph and as well as this, उसके साथ flood and flood routing. Then it may happen कि third session में we will revise all the segments along with problems. Revise all the segments along with problems, previous year problems, to finish it up this chapter. 15 hours is we will not take more than 4 classes. It's a brush up course. It's actually a crash course type of thing. But not only the important parameters, we will be touching each and every point in the aspect of gate and IES. We'll be touching each and every point in the aspect of gate and IES. Now we are going for another important segment, that is measurement of mean precipitation. We are going for another important segment, that is measurement of mean precipitation. कल सुबह 7 बजे का है सुमन। And tomorrow's class will be of 3-hour sessions. वैसा ही सेगमेंट किया हुआ है, मेजरमेंट ऑफ मीन प्रेसिपिटेशन। आज जब तक चलेगा देखेंगे, जितना हो सके थ्योरेटिकल एस्पेक्ट्स में डिस्कस करेंगे। Now when we are talking about the mean precipitation measurement, the first process is we need to find out, that is the arithmetic mean method. arithmetic mean method. This method is used when the following conditions are satisfied. Catchment should be flat and plain. Rain gauging stations are uniformly distributed. Rainfall recorded by the rain gauging stations are having very less variation. So from the condition itself, you can understand that it is very much coarse conditions. So if P1, P2 to Pn are the rainfall recorded by 1 to n stations, then P bar will be equals to P1 plus P2 to Pn, just normal arithmetic process by Pn, which is summation of Pi I equals to 1 to n by n. The summation of Pi I equals to 1 to n by n. That is arithmetic mean method. Second one is having higher applications. That is Thyssen polygon method. Thyssen polygon method. This method is also called as weightage area method. And in this method, each and every rain gauging stations will be associated with some geometrically assigned areas. Like if this is your total area, so these are the rain gauging stations. So this one is A1, A2, A3, P1, P2, P3 is the precipitation data measured. So suppose 1, 2, 3 precipitation measures P1, P2, P3, area assigned A1, A2, A3, then P bar will be equals to P1 into A1 by A. Total area is A. Total area is A. Plus P2 into A2 by A. Like that, it will go on to Pn into An by A, where Ai by A is called as Thyssen weightage. Is called as Thyssen weightage, and P bar is actually P1A1 plus P2A2 to up to PNAN by whole area A, or it can be told as summation of PI I equals to 1 to N by total area A. That is your Thyssen polygon method. Actually, it is done by forming certain polygons, but forming the polygons is not our point of concern in not neither in GATE nor in ESE. That's the final form I am writing here. Now, third one is isoheital line or isoheital method. So first we need to know what is isoheight. It's an imaginary line which joins those points of a catchment where having equal annual precipitation or rainfall. It's an imaginary line. It's an imaginary line which joins those points of a catchment which are having equal annual precipitations or rainfall. So it is an imaginary line which joins those points of a catchment which are having equal annual precipitation or rainfall. Another line is there called as isonif line. I'm just writing the definition here. Once again, an imaginary line which will join those points of a catchment which is having equal amount of snowfall. So this height line, it will be showing for equal rainfall. Isonif is for equal snowfall. It is an imaginary line which will join those points in a catchment which will have equal amount of snowfall. And it's the best method to find out the mean precipitation. No preconditions are required. Suppose this is area, this is the isohydral line P1, P2. So it's actually Pi plus 1, Pi plus 2 like this. Let P1, P2, P3, Pn are the isohydral line passing through a catchment. Let two isohydral line Pi and Pi plus 1 and the area engrossed between them, area engrossed between them is Ai. In area Ai, mean precipitation will be Pi plus Pi plus 1 by 2. In that area, volume of rainfall occurred is Vi, which is equals to Ai into Pi plus 1 by 2. So total volume of rainfall occurred V is equal to summation of Vi. So the mean precipitation will be the total volume P bar by total area V by A, that is equals to summation of Vi by A, or P bar, you can write it as, what is V bar? The sum Vi is summation of I equals to 1 to n Ai into Pi plus 1 by 2 whole by A. That is your isohytal line formula. Isohytal line formula. Hope it is clear to you. Let's quickly have a look on this measurement of mean precipitation. Quickly have a look on this measurement of mean precipitation. Then we'll go for the last lab of this precipitation segment, that is frequency of rainfall. We'll go for the last lab of this precipitation segment, that is frequency of rainfall. So first one is arithmetic mean method. Second one is Thyssen polygon method. Then we are going for the isohytal method. That is the final formula. Just a minute. Let's go for the frequency of rainfall. The frequency analysis on rainfall event is performed to find out the return period and occurrence interval of random, rare, and extreme events. How to find out the return period? So first we need to go for the empirical formulas for return period T. Empirical formulas to find out T values. First of all, Webull's formula T equals to n plus 1 by m. What is n, what is m, I will explain. Then Hazel's formula T is equals to n by m minus 0.5. Third one is California formula T equals to n by m. N is the number of sample, M is the rank assigned. How to assign the rank? I will explain. Now, next we are going for the steps to find out the t-value. Arrange any data or arrange the data. First, we need to arrange the data set in descending order. Larger to lesser value. Assign rank, that is the most important part or step of this job. And then you can apply any formula. Just I'm going through an example to make you understand the process. Find out the T of event x3 arbitrary number from the following data set. X5, X3, X4, X2, X3, X1, X6, X3, X2. This is the event. And it is given that X1 is the highest one. So actually given as X1 greater than X2 greater than X3 greater than X4, X5, X6. What is the job? What is the first step? You need to arrange the data set in descending order. So highest one is X1, then X2, two X2s are there. Write down. Then X3, three X3s are there. Then X4, then X5, then X6. You need to assign rank. Rank is assigned according to their position. X1, position 1. X2, position 2. Now see, if one X2 is getting rank 2, another X2 will also get rank 2. That is the hinge. Now what will be the rank of this X3? I have told you, when you are assigning a rank to a new event, it will be according to the position. It will be rank 4. So each and every X3 will have rank 4. Then this X4 is having rank 7. This is 8. This is 9. Hope it is clear to you. Now for X3, what is the rank? Getting 4. So T, let's apply Weibull's formula. It is the most used formula. Weibull's n plus 1 by m. N plus 1 by m. It will be n is 9 here. 9 plus 1 by 4. 2.5 year. That means X3 will get repeated within 2.5 years. Is that clear? Is that clear? That is the frequency of rainfall. Then we are going for the risk analysis part. Risk analysis, which will be defined by certain formulations only, that we need to have the essence of risk analysis, which will be required for short one number mathematical questions. Suman, the concept of frequency analysis is done. Is it required with any doubts from anybody? Now we are going for the last lab, that is risk analysis. Any doubts, Suman? First formulations. If T is the time period of an event and P is the probability of occurrence P equals to 1 by T and Q equals to 1 minus P, where Q is the probability of non-occurrence of that event. हम लोग x3 क्यों लिए सुमन? क्योंकि हम लोग x3 का वैल्यू पूछा गया था. देखिए आप एग्जांपल में देखिए, फाइंड आउट द t ऑफ इवेंट x3 फ्रॉम द फॉलोइंग डेटा सेट. आप किसी को लेके भी कर सकते हैं. x1 को लेके करेंगे तो रैंक 1 होगा, x2 को लेके करेंगे तो रैंक 2 होगा. Is it okay? Second one. Suman, hope you understand that. I didn't get any reply, that's why I'm proceeding. Probability of occurring of an event n times or r times in n successive years. That will be much easier notations. NCR P to the power R Q to the power N minus R. NCR is factorial N by R factorial into N minus R factorial P to the power R Q to the power N minus R. Third one, probability of non-occurring of an event in n years. Non-occurring means 0 times in n year. मतलब प्रीवियस फॉर्मूला को अगर हम देखते हैं कि 0, क्योंकि r है आपका 0 ईयर, NCR था तो NC 0, P to the power 0, Q to the power n minus 0, which is equals to factorial n by factorial 0, n minus 0 factorial. P to the power 0 is 1, it's Q to the power n. This is 1 only, so it's Q to the power n. Formula number 4, probability of occurring at least once in n years is risk R 1 minus Q to the power n. Percentage safety is 100 minus percentage risk. Point number 6 is nothing but point number 5, and is not a formula, actually a note we need to remember. When probability expressed in fraction, it will be called as exceedance probability. When it is expressed, when probability expressed in percentage, it is called as chance percentage. It's called as chance percentage. This is the end of the precipitation thing. एक बार देख लेते हैं हम लोग क्या डिस्कस किए हैं अभी तक. चालू किए थे हाइड्रोलॉजी का कॉन्सेप्ट से. Different components of hydrology we have discussed. Gone for water budget equation, then solve one question, then entering to the precipitation. Different forms of precipitation we have discussed. rainfall, snowfall, drizzle, hail, blaze. Then we have gone for the characteristics of rainfall, depth, duration, intensity, and return period. Rainfall measurement, adequacy of rain gauge station data. Gone for all the problems. One problem we have discussed. Then we have gone for the continuity preparation of data, where we have gone for two things: continuity measurement and consistency measurement. Simple mean method and normal ratio method. Consistency measurement is done by double mass curve. Representation of data is done by the mass curve. Then hydrograph, we have gone for the hydrograph concepts. IDF, TDF curve, DAD curve, we have discussed. Then we have gone for the discussion of arithmetic mean method in the measurement of mean precipitation, Thyssen-Polygon and isohydral method. Then we have gone for the frequency of rainfall and risk analysis. I have completed the precipitation, the second most important part of this hydrological segment. Don't forget to subscribe the channel and join our Telegram group for latest updates on our upcoming videos. And don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10 for any kind of subscription process. And hit the bell icon for the notifications. Now we will move to the abstract of precipitation, where we will go for the evaporation, transpiration, infiltration and runoff. Before going to that, let's take a break of 5 minutes. It's 9:37. We will start our restart our classes. Restart means don't go anywhere. Don't go anywhere. Streaming will be there. I'm just taking a pause of 5 minutes.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for the gate till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Well, now we are going for the official chapter 2. That's evaporation and transpiration. Ideally, it is chapter 3 actually. So, let's start with the discussion of abstract of precipitation. क्या है ये? From the abstract, from the precipitation, whatever is formed, like precipitation होने के वजह से पानी मिलता है कोई नदी तालाब लेक को, वहां से आपका होता है evaporation. Transpiration is due to the precipitation, water is going to the soil surface, then only you will then only this trees, the plants will get water that will be transpired later on. That is abstract of precipitation. Infiltration, beneath the soil surface, whatever is going, it will be called as the infiltration. And runoff, above the soil surface, whatever is flowing, that is also the excess precipitation. So it's abstract of precipitation. So what are the abstract of precipitations? Evaporation, transpiration, infiltration, and runoff. These are the abstract of precipitations. Now, apart from these four, there is another loss which is called as interceptional losses. What is interceptional loss? क्या होते हैं कि कभी कभार बिल्डिंग के वजह से Rainwater will not be able to reach to the ground surface. सिर्फ बिल्डिंग नहीं, पेड़ पौधे, लंबा पेड़ पौधे के लिए भी एक चीज हो सकता है. Now, without reaching the ground surface, some precipitation will be lost to the atmosphere due to the interception of rainfall for the presence of tall objects above ground. This is called as interceptional loss. So, without reaching the ground surface, some precipitation will be lost to atmosphere due to the. Suman, please check now. Okay. Sorry for this technical glitches. क्या है कि मैंने पढ़ा रहा था कि interceptional losses without reaching the ground surface, some precipitation will be lost to atmosphere due to the interception of rainfall for the presence of tall objects above the ground. और सुमन, मैं आपका क्वेश्चन का आंसर भी दिया था, आपको पता नहीं सुनाई दिएगा कि नहीं, कि आपने क्वेश्चंस किए थे कि व्हाट इज क्यूमुलेटिव एनुअल रेनफॉल मींस. मैंने उस टाइम पे चैट नहीं देखा था थोड़ा सा. सो क्यूमुलेटिव एनुअल रेनफॉल मींस, क्यूमुलेटिव मतलब प्रीवियस वैल्यू के साथ एडिशन होते हुए. सपोज 2001 के लिए और 2002 के लिए आप प्लॉट कर रहे हो. 2001 का एनुअल रेनफॉल है P1 एंड 2002 का एनुअल रेनफॉल है P2. तो 2001 का एनुअल जब प्लॉट करोगे तो P1 फॉर 2001, लेकिन फॉर 2002 इट विल बी P1 प्लस P2. सुनाई नहीं दे रहा है आपको अभी भी? Suman, now you are able to listen the class, then you can proceed. I hope the technical issues are now solved. Clear na? Okay. So what we are discussing, the evaporation, that is a loss of water. मैं पहले भी discuss बोल चुका हूँ. It is a loss of water in the form of water vapor. Latent heat of vaporization will be supplied by water body or soil itself. Latent heat of vaporization will be supplied by the water body or soil itself. Now, the rate of evaporation will be depending upon certain factors. I have listed here 7 factors, major 7 factors. Just give me a minute, please. So for the difference in vapor pressure, actually, that is a major one I have told you previously. So what are the factors? Difference in vapor pressure, temperature, wind speed, surface area of water body, humidity, atmospheric pressure, and quality of water. For the difference in vapor pressure, which is the major one, I have told here, evaporation loss, as it is the loss of water, that's why EL is directly proportional to EW minus EA, where EW is the saturation vapor pressure and EA is the in water saturation vapor pressure in air. So eventually, to remove this proportionality sign, EA will be K, EW minus EA, which is Dalton's law for evaporation loss. It is Dalton's law for evaporation loss. K is called as the Dalton's constant. That is for the difference in vapor pressure. For temperature, the evaporation loss will increase with the increase in temperature. The evaporation loss will get increased with the increase in temperature. For wind speed, it will increase up to a certain point, then it will be fixed. The point up to which the wind speed will get, the evaporation loss will get increased is called as critical velocity. सरफेस एरिया, आप बचपन में देखे होंगे कि कोई चाय वाय पीते वक्त उसको प्लेट में फैला लेते हैं क्योंकि सरफेस एरिया विल बी मोर, दैट विल गिव यू मोर इवापोरेशन एंड लॉस. Humidity, obviously humidity मतलब more EA. If EW is fixed, so quite obviously evaporation loss will be less when humidity is more. जितना ज्यादा एयर में मॉइस्चर कम रहेंगे, इवापोरेशन लॉस उतना ज्यादा होंगे. Atmospheric pressure, as evaporation loss is the upward direction, atmospheric pressure is the downward direction process. So EL once again inversely proportional to atmospheric pressure. And quality of water, it's also the inverse proportional process. मैंने एक ही स्लाइड में सब कुछ लिख लिया क्योंकि you can remember it. Difference in vapor pressure मेजर है जो डाल्टन्स इक्वेशंस के हिसाब से डिफाइन किया गया है. टेम्परेचर जितना बढ़ेगा इवापोरेशन लॉस उतना बढ़ेगा. Wind speed, up to certain speed, evaporation loss will be higher, then it will get constant. Surface area of water body is provided, is directly proportional. Humidity inversely proportional, atmospheric pressure inversely proportional, quality of water is inversely proportional. Everything is discussed here. Now we are going for the measurement of evaporation. We are going for this measurement evaporation. First of all is pan evaporation. Empirical equation process. Analytical equations. Three ways are there. Now, in case of pan evaporation, what will happen? There will be a pan, different types of pan are there. Colorado pan, Indian standard pans. Water will be there. It will be kept for a particular catchment area. It will actually define a catchment area. It will be kept outside. Evaporation losses will be defined. Depth of water will be measured. उसके ऊपर precipitation होता है तो उसको भी measure किया जाता है. Generally, pan evaporation is done by evaporimeter, where actual evaporation is CP, coefficient of pan in pan evaporation. प्रॉब्लम जब सॉल्व करेंगे इसका कॉन्सेप्ट और भी क्लियर होगा. कोएफिशिएंट of pan. The CP value will be different for different types of pan. So जब आपका water depth जो है, water depth जो जितना initial depth से बढ़ेंगे, so it is getting more precipitation if other losses are negligible. अगर घटता है तो evaporation is more than the precipitations. Now for different types of pan, CP values will be different. We need to remember certain pan's coefficient values. For class A pan, IS pan, Colorado pan, and USGS, United States Geological Survey pan. CP values are for class A pan, it's 0.7, it's 0.8, it's 0.78, it's 0.8. Okay. Now, by the empirical equations, the second one is by different empirical equations. First formula is Fitzgerald equation. एक चीज है कि आपको ये इक्वेशंस याद नहीं रखना है. जो है इसका प्रोसेस जो है उसका अगर कोई हिंच है जो मैं अभी लिख भी दूंगा वो सारी चीज याद रखना है. इक्वेशंस आपको याद नहीं रखना है. In case of Fitzgerald equation, EL, which will be in mm per day, that will be equals to 0.4 plus 0.124 into V into EW minus EA, where V is the wind speed किलोमीटर पर आवर। सुमन आपने पूछा है कि सैचुरेशन वेपर प्रेशर मीन्स द इफ द एयर इज सैचुरेटेड विद वेपर, जितना चाहिए उनके वाटर उतना ही है, तो उसके जब उड़ाते हैं तब एक प्रेशर होता है उसका, ऑब्वियसली वाटर इज देयर, सो वाटर वेपर इज देयर, उसका एक प्रेशर रहेंगे, दैट इज कॉल्ड एज सैचुरेशन वेपर प्रेशर। Eventually, it is representing the maximum amount of vapor that can be entrapped by air, and EA is actually the actual vapor pressure. So EW and EA are the saturation and actual vapor pressure. Represented in mm of Hg. Now the second equation is Mayer's equation. The second equation is Mayer's equation, where EL that is in mm per month. ये सारी चीज आपको याद रखना है भैया कि अगर फिट्जरल्ड इक्वेशन है तो EL का वैल्यू किस में रिप्रेजेंट हो रहा है, अगर मेयर्स इक्वेशन है तो AL का वैल्यू किस में रिप्रेजेंट हो रहा है, Km into 1 plus 0.06215 into V into EW minus EA, where Km is Mayer's constant और EW और EA का मतलब सेम है, saturation vapor pressure and actual vapor pressure in mm of Hg. And if V is the wind speed if V is in meter per second, then Km value will be 0.64 and V is in kilometer per hour, Km will be 0.36. If you remember, अगर V का वैल्यू आपका मीटर पर सेकंड में है तो Km will be 0.64 and if it is in kilometer per hour then Km will be 0.36. सुमन आपका मैं सैचुरेशन वेपर प्रेशर वाला आंसर दिया हूं, इज इट क्लियर? The third one is Rover's equation. Suman, are you there? Please reply. For Rover's equation, EL, which will be mm per day, will be equals to 0.71 into 1.465 minus 0.00732 into PA into 0.44 plus 0.07334 into V into EW minus EA, that is Rover's equation, where PA is the atmospheric pressure in mm of Hg. V is the velocity in of wind in meter per second. Those who are present here, you can tell your friends to join if they require. We are going for a marathon classes continuously 3 days. So we are discussing the analytical methods. So in analytical methods, I'm just showing you that suppose this is your. So in analytical methods, I'm just showing you. So this is suppose this is your lake or any kind of water body. So what is Hn? Is net heat energy entering the water body. Ha is heat energy lost to atmosphere due to radiation and conduction. Heat energy lost to evaporation heat energy transferred to ground surface, Hg. Hs, heat energy stored in water body, amount of heat lost due to some flow of water. क्या है कि stored Hs, Hi ये सबको negligible पकड़ सकते हैं आप. So assume so Hn is Ha plus Hg plus Hg, but Hg is the heat loss due to evaporation is rho LEL, where L is the latent heat of evaporation and rho is the density of water. So He is equals to Hn minus Ha plus Hg. So rho L EL is equals to Hn minus Ha plus Hg, or EL evaporation loss is equals to Hn minus Ha plus Hg whole by rho into L, and Ha is actually and Hg both are in the opposite direction. So the summation, if we take it as negligible quantity, then from there EL will be equals to Hn by rho into L, where Hn will be watt per meter square unit, EL will be meter per second, rho is in kg per meter cube, and L will be in joule per kg. Joule per kg. And EL will be in meter per second, that I have written. Okay. Now, there is one ratio called as Bowen's ratio. The ratio called as Bowen's ratio is actually defined as beta, which is Ha by Hg, which is Ha by Hg is rho L EL. Sorry, written wrong. He. Simply sorry. Now, empirically, beta is 6.1 into 10 to the power minus 4 PA into TW minus TA by EW minus EA, where PA is the atmospheric pressure in mm per Hg that we know, and TW and TA is the water and air temperature in degree centigrade. Water and air temperature in degree centigrade. Now I'm discussing the methods to control the evaporation loss, methods to control the evaporation loss. It can be by using any mechanical cover so that it is not getting exposure to the atmosphere, or any kind of floats, lightweight brick to reduce the surface area. And by using chemicals, but before using chemicals, you have to ensure that it should not be toxic and it should not give any color to the water. Example, cetyl alcohol and sterile alcohol. The example of this controlling the evaporation loss itself. So now we are going for the transpiration. After evaporation, we will go for the transpiration. So now we are going for the transpiration. So पहले ही हम इसका definition देख चुके हैं. What is the definition? Yes, Suman, correct. There's a loss of water from the soil surface to atmosphere. So what is transpiration? It is the loss of water from the soil surface to atmosphere in the form of water vapor. अभी तक तो पूरा ही इवेपोरेशन के साथ सेम था. नेक्स्ट लाइन है थ्रू प्लांट बॉडी. दैट इज द डिफरेंस. In the form of water vapor through plant body. What is the basic difference in evaporation and transpiration? Remember, evaporation is a whole day process, but transpiration is daylight process. In the night time, transpiration will not occur. The basic difference is evaporation is whole day process, but transpiration is a daylight process. Evaporation is whole day process. Transpiration is daylight process. Evaporation is whole day process, but the transpiration is daylight process. Remember, in lab, transpiration is measured by phytometer. One thing you need to remember, I'm just pointing out the things, that is called as transpiration ratio. Transpiration ratio, TR. It is the total mass of water consumed by a plant, mass of water consumed by a plant during its full growth. By mass of dry matter produced inside the plant body during its full growth. That is transpiration ratio, and should be in between 300 to 500 for perfect cropping. Total mass of water consumed by a plant during its full growth and mass of dry matter produced inside the plant body during its full growth is called as the transpiration ratio. And the value should be in between 300 to 500 for perfect cropping. Now we are going for the factors affecting transpiration. The factors which will affect the transpiration, that will be of three types. One is weather factors, next one is plant factors, characteristics, and soil characteristics. So first one is weather factors. Sunlight, quite obvious, according to its daylight process. Humidity, temperature, vapor pressure part is as same as the evaporational process. Vapor pressure, and wind speed. These are weather factors. Then you are going for plant characteristics. Age of plant, growth rate, growth stage. Each and every term is self-explanatory. That's why I'm not telling anything. Surface area of leaf, type of leaf. Now finally, the soil characteristics. Porosity, amount of soil moisture present, water retentivity of soil and type of soil. So ये तो सारे फैक्टर्स हैं, सही हैं, लेकिन इसके बाद सेकंड ड्राई मैटर मतलब बॉडी वेट. हम भी जैसे अगर हमारे बॉडी का भी आप देखते हैं तो इट्स 70% वाटर, 30% इज ड्राई मैटर. द एग्जैक्ट मास विच इज एक्चुअली देयर इन आवर बॉडी, दैट इज ड्राई मैटर. ओके, now a very important concept we are going to discuss. इसके बाद से जितना ही है एक इंपॉर्टेंट कॉन्सेप्ट ही आपके पास है, पूरा ही एक कॉन्सेप्ट के ऊपर बेस करके जब तक ना हम लोग एस्टिमेशन पे जा रहे हैं, पूरा ये कॉन्सेप्ट के ऊपर बेस करते हुए हमारा डिस्कशन चलेगा. सो प्लीज बी केयरफुल, ध्यान से सुनिएगा क्या हो रहा है. मैं बोलने के साथ साथ लिखूंगा भी, मेक द प्रोसेस फास्टर. सो जब जो पानी आपका लॉस हो रहा है, कहां से? सॉइल से. दो तरीके से लॉस हो रहा है. कैसा, क्या क्या? एक तो है सॉइल से एटमॉस्फेयर में जो पानी जा रहा है वो या तो पेड़ पौधे के हिसाब से जा रहा है, पेड़ पौधे के जरिए से जा रहा है, और नहीं तो आपका सॉइल पोर्ट से इवापोरेशन हो रहा है. सो वाटर लॉस्ट फ्रॉम सॉइल to atmosphere due to two reasons. क्या reason? एक तो है water consumed by plant, water consumed by plant, और second है evaporation from soil pores. ये जो वाटर कंज्यूम बाय प्लांट है, जो पेड़ अपने रूट से जो पानी लेता है, उसका दो तरीके का यूज करते हैं. ये टू टाइप ऑफ यूजेस. वन इज थोड़ा सा पानी इसका बॉडी वेट के लिए जाता है, इंक्रीज द बॉडी ग्रोथ, और बाकी होता है ट्रांसपिरेशन. सो फर्स्ट इज ट्रांसपिरेशन, and second one is water used for its body growth. अब कहानी है कि water used for its body growth is negligible when it is compared to transpiration process. So we can say that water lost from soil to atmosphere is almost equal to the process of evaporation plus transpiration combinedly, which is called as evapotranspiration. Combinedly, it is called as evapotranspiration. Clear? And the term should be introduced is called as the consumptive use. Consumptive use जो है CU, by definition the total amount of water consumed by plant due to its full growth. So किस चीज के लिए देता है ये? ट्रांसपीरेशन प्लस consumption of water due to growth, है ना? Now consumption of water due to growth, obviously it will be negligible when it is compared to transpiration. So eventually Cu is almost equals to the transpired water So what is evapotranspiration? Evaporation plus transpiration. Once again, अगर evaporation और transpiration loss को compare करते हो, so then transpiration loss through the soil के हिसाब से, मैं evaporation loss from water surface that is different. मैं soil के हिसाब से बोल रहा हूँ. Transpiration loss will be much higher. So eventually, consumptive use of CU is equivalent to evapotranspiration. That is equivalent to the evapotranspiration. Now, next concept is field capacity. है क्या ये? Try to understand very carefully. देखिए, ये आपका सॉइल सरफेस और ये आपका ग्राउंड वाटर टेबल, बीच में है सॉइल पोर्स. जब when rainwater is coming, the water is percolated through the soil pores and going to the groundwater table. ग्राउंड वाटर टेबल के नीचे जो पानी है वो तो है ग्राउंड वाटर, लेकिन सॉइल पोर्स में जो पानी एंट्रैप्ड है वो क्या है? दैट इज द सॉइल मॉइस्चर. ये पेड़ पौधे ये सॉइल मॉइस्चर लेते हैं, ग्राउंड वाटर नहीं. ग्राउंड वाटर हम निकालते हैं बाय विथ डिफरेंट टेक्निक्स आर देयर. क्लियर? Correct. So, when the water is actually going to the groundwater table by the force of gravity, और यहाँ पे जो soil moisture है वो उसको होल्ड करके रख रहा है, so उसका भी एक कैपेसिटी होगा. So field capacity is the maximum holding capacity of soil to hold the soil moisture against the force of gravity defined by FC. It's the maximum holding capacity of soil to hold the soil moisture against the force of gravity is called as field capacity. So the maximum holding capacity of soil to hold soil moisture against the force of gravity is called as the field capacity. तो जितना पानी आप वो होल्ड कर रहा है, सोचिए कि टोटल एक्स अमाउंट ऑफ पानी वो होल्ड कर रहा है, जो आपका फील्ड कैपेसिटी है. कुछ पानी होगा फिजिकली बॉन्डेड वाटर, जिसका क्वांटिटी है y, और कुछ पानी होगा केमिकली बॉन्डेड वाटर, जिसका क्वांटिटी है z. सो एक्चुअली x इक्वल्स टू y प्लस z. जो केमिकली बॉन्डेड वाटर है उसको कहते हैं हाई ग्रोस्कोपिक वाटर. हाई ग्रोस्कोपिक वाटर. अब बात यह है, ये पानी पेड़ पौधे लेंगे या तो सॉइल मॉइस्चर फॉर द यूजेस. द पॉइंट इज द सॉइल विल नॉट अलाउ एनीथिंग टू डिप्लीट दिस केमिकली बॉन्डेड वाटर. ये जेड वाला कंपोनेंट ये कभी छोड़ेगा ही नहीं. ऊपर वाला पेड़ पौधे मर भी गया, बोलता है कि भैया पानी दे दो, तब भी ये छोड़ेगा नहीं. Y is actually the available moisture which is not equal to its field capacity, and this is called as permanent wilting point, PWP, called as the Wilting point means the death point. Physically bonded water can be released by soil. फिजिकली बॉन्डेड वाटर टोटल कैन बी रिलीज बाय सॉइल. तो मतलब क्या है, ये जेड वाला अमाउंट जो है, मतलब सोचिए कि भैया आपके पास 100 रुपया है और आप घर से आए हैं क्लास करने के लिए, और आपके घर जाने के लिए 20 रुपया ऑटो में लगता है. आपका घर आपके कोचिंग से 35 किलोमीटर दूर है, जस्ट एग्जांपल, और मैं आपसे उधारी मांग रहा हूं, बोला कुछ पैसा दे दीजिए, कुछ काम है. ऐसा हो सकता है कि उस 100 रुपया में आपका खाना खाना था, कुछ भी करना था, लेकिन आप बोले कि ठीक है सर मांग रहा है पैसा देते हैं, लेकिन कितना पैसा देंगे, अब 80 रुपया ही देंगे, क्योंकि अगर पूरा 100 रुपया दे देते हैं तो आपको पैदल जाना पड़ेगा 20-35 किलोमीटर. दैट इज नॉट पॉसिबल. आप भूखे रह सकते हो लेकिन पैदल 20-35 किलोमीटर इज नॉट पॉसिबल. सो 80 is the available money and that 20 is the permanent wilting point. मैं आपके हाथ पैर भी जोड़ लूंगा तो आप बोलेंगे कि सर माफ कर दीजिए, वो 20 नहीं दे पाएंगे. दैट इज द केमिकली बॉन्डेड वाटर. So field capacity minus permanent wilting point is available moisture. शेखर भाई समझ में आया? तो भैया मैक्सिमम कितना लॉस हो सकता है पानी? पोटेंशियल इवापोट्रांसपिरेशन is equals to the available moisture. So PET, potential evapotranspiration, will be equals to available moisture. PET is nothing but the potential evapotranspiration. Soil hold the chemically bonded water for its own purpose. To retain the soil, to retain the bonding between the soil particles, to retain its own property, it requires some water molecules, that is chemically bonded water. They will hold the chemically bonded water for their own purpose. So that is the maximum that can be withdrawn. So actual value will be actual evapotranspiration. Actual evapotranspiration AET will less than equals to PT. या उसका same होगा नहीं तो कम हो गए. And there is a term called as RDT index, AI, is equals to PT minus AT by PET into 100. Now we are going for the estimation of evapotranspiration. can be done by laboratory measurement. Lab measurement is done by lysimeter instrument. By empirical equations. Two equations are used. One is Penman's equation. Another one is Blaney-Friedel equation. Next is Penman's equation. It is actually the combination of mass and energy balance based on thermodynamics. Where PET, potential evapotranspiration, will be equals to AHN plus EA into gamma whole by A plus gamma, where PET will be in mn per day. This is important to remember. And A is the slope of saturation vapor pressure versus temperature plot. सेकंड मेरा मैं भी बहुत ज्यादा ही सैचुरेशन पॉइंट में हूं और दो मैक्सिमम 5 मिनट्स रिक्वायर्ड टू कंप्लीट दिस ओनली Blaney-Friedel इक्वेशन करके आज का क्लास खत्म करेंगे। फिर कल इनफिल्ट्रेशन चालू करेंगे, रन ऑफ पढ़ेंगे, हाइड्रोग्राफ पढ़ेंगे। H is net heat energy received by soil moisture gamma is called as psychometric constant. .49 जिसका वैल्यू है and EA is empirical constant. Now we are going for the Blaney-Friedel equation, the last thing. Friedel equation. Where PET will be kPm by 100, where PET will be in inch per month. यूनिट जो है वो दिक्कतें करते हैं। 1 inch is equals to 2.54 centimeters provided to you. And PM समझ में आ रहा है, ये सब ब्रिटिश लोगों का इक्वेशन है, अपने हिसाब से किए हुए हैं। मीन मंथली टेम्परेचर in degree Fahrenheit. Now, if T in degree centigrade, then Tm will be 1.8 T plus 32. Just इसको degree centigrade में conversion. K is called as consumptive use factor or crop factor. K is consumptive use factor or crop factor, which is nothing but consumptive use by pan evaporation. And here P is the percentage daylight hour for a month. ठीक है? Yes, used by irrigation engineers. Same process, same thing will get there. So that is the end of transpiration also. So that is the we are going for the first class of this marathon session. Let's crack GATE and ESE. Don't forget to apply my code SEN10, myself Soumyajit Sen. Subscribe our channel and hit the bell icon for notifications, and also join our Telegram group for latest updates on our upcoming videos. Tomorrow morning 7 AM we will be going for the second session of this marathon class, where we will deal with infiltration, runoff, hydrograph. कल का क्लास के बाद आप हाइड्रोलॉजी का मैं इतना गारंटी से बोल सकता हूं कि अगर आपका 2 से 3 मार्क्स आ रहा है तो दैट यू आर डन विद दैट. One more segment will be there that is very important to well hydraulics. That also I will discuss. कल का सेगमेंट में अगर हाइड्रोग्राफ हो जाता है, then in the Sunday's class we will first go for the well hydraulics, then in time remaining we will start do some problems, and one more class will be there for problems, revision, process, flood routing, and we will be over with the hydrology. Today's sessions for almost 4 hours, 45 minutes, like that, almost 5 hours. We have gone for the sessions of, started with the discussion like introduction of hydrology, then precipitation. All the precipitations are done. We have gone for the infiltration and runoff itself. And if you like my classes, go to the app. If you don't have the app itself, go to the app. There also I keep on taking classes. There I will take special class of multiple select questions from hydrology and environment itself, both. Follow me there. My name is Soumyajit Sen. My code is SEN10 SEN10. Follow me there if you don't have the Thank you, Shekhar. Please refer to your friends for tomorrow's class and don't miss tomorrow's class. कल सुबह थोड़ा जल्दी उठ जाना भैया, मेरे को भी उठना है. 6:30 बजे के आसपास नहाना भी है, नहा के बैठ जाएंगे पूजा करना हाइड्रोलॉजी का. Follow me there. I will keep on taking in the class in the app. हाइड्रोलॉजी का भी क्लासेस होंगे and multiple select questions we will be practicing soon for your GATE process, newly introduced in this year GATE. इंस्टॉल अनअकैडमी लर्निंग है. आइकॉनिक सब्सक्रिप्शन प्लस सब्सक्रिप्शन बारे में मैं पहले भी बोल चुका हूं और नहीं दोहरा रहा हूं अभी. Don't forget to apply the code SEN10 SEN10 for any kind of subscription you are taking. These upcoming batches, links are there. And next Unacademy Combat goes live on 26th of January, 6 p.m. For today, good night. We'll see you tomorrow morning, 7 a.m. for the next session of this marathon class. Goodbye.